This topology is very stupid. If you look at it just offhand, there's a couple of things you can see that are totally wrong with it. One is that here we have a serial connection between R1 and R2. One is in the 192.168.0.0/24 network. This one is in the 172.16.0.0/16 network. They can't possibly talk to each other because they're, in different networks. But here's another problem. On both of the routers, this interface and this interface have the same IP address. That's not really possible, is it? Well, let's take a look. Okay, here's router 1, router 2. This is PC1, PC2. These are VPCS containers that you get in GNS3. So first let's take a look. Let's make sure that we have the right addresses here. I think that's right. Yep, okay. So here we've got 192.168.0.2.24. The gateway is correct. And 172.16.0.2 with a .1 gateway. And the correct mask. Yep. All right, now let's take a look at the routers. Oops, typoing like a fiend here. Well, yeah, there they are. And we can see that we have an OSPF route to the 172.16 network via the serial port. Let's just do it on this side just to make sure. Yeah, everything looks all right there. So what's going on here? Well, here's our first clue. Serial ports on both sides say that they've received their addresses through TFTP. And you think, well, that's crazy. You can't really do that through TFTP unless you're importing the entire config from TFTP. And besides, the fast Ethernet interfaces are set manually, like any sane person would do. That's true. I've got to tell you, this TFTP thing, this is a little deceptive because in iOS, all this means is that you're pulling this address from some other place. It doesn't have to be a TFTP server. And I'll show you what's going on there in a second. First, let's make sure we have connectivity, because this will, if this network works, then this ping should work. 16.02, that's over to that side. Okay, we have got a couple timeouts while they're ARPing, but then it worked. Let's try pinging over here. 802. Yep, and that looks exactly like it should. So this network is functioning. Now this is a good trick to play on your friends who may be studying for CCNA, just to kind of confuse and dumbfound them. And honestly, it was a little confusing to me. And the key to this whole topology working is something called unnumbered interfaces. And let's do a show run here. So here you can see this is exactly how we expect it to be. Our fast Ethernet 00 addressed manually like this. And here's the serial port on this side. Let me just get it highlighted here. Yep, 000. IP unnumbered fast Ethernet 00. Now what this means is that on a serial link, point-to-point link, because technically you don't even need an address, you can pull that address from any other up-up interface. In this case, we're pulling it from the fast Ethernet interface. And on this side, we've got the same thing. Both routers are running OSPF, so they're advertising their own networks over the serial interface to each other. Yep, here's a hello packet. It's perfectly fine. They're CDPing to each other. So they're successfully communicating over the serial link despite the fact that these two addresses are on completely different networks. And the reason for that is kind of long and boring, but it basically boils down to that if you have a point-to-point serial interface, you don't technically even need an IP address. If you want to play this trick on people, I'll just show you what the command is. Let's go to our serial. No IP address. I've just brought this down so I can re-enable it. And the command for this is you get on the serial interface, IP, unnumbered, and then where you're pulling it from. In this case, we're pulling it from FAST00. And now we can see all the OSPF LSAs are updating each other, and our network is functioning again. Now, this may look like a stupid trick, and it is kind of a stupid trick, but there actually are good reasons for using unnumbered interfaces. And I'll just show you briefly one possible use for them once I create a new topology. So here we have a topology which kind of makes sense. These are a bunch of routers that are all connected in a wheel and spoke formation to the central router by serial ports, and there are places where this makes sense. What we're going to do is first we're going to configure all of the outer routers with loopback addresses, and then we're going to make these serial ports that face inward, mirror them as unnumbered, and also enable OSPF on everything, and then we're going to wind up doing the same for router 1, but mirroring loopback on all 6 of these so that they all have the same IP address. Let's just take a look at router 2 here. It's bad practice to use 2222 because that is actually an internet. Yeah, let's make it private. And then so this will come up and eventually it will go down because there's nothing for it to talk to yet. However, while we're waiting, and this just puts our loopback network into area 0. Okay, and I'm going to go around and do this with all of these routers. And now, just like R2, every single router around the outside of this hub and spoke setup is going to get a loopback address. They're going to get a 10 dot whatever address /32, and their inward facing serial port is going to be unnumbered, reflecting that loopback address. And so now let's open up router 1. See what happens here. We're going to just configure this exactly the same, except we're going to make every single one of these serial interfaces unnumbered with the same address. Now at this point I decided to try int range on the serial ports, although I didn't think it would work, and I was right, they don't work. So if you want to try this one at home, you're just going to have to configure every serial port manually. No big deal. Oh, and you will have to do this on actual equipment or GNS3 because it won't work in Packet Tracer at all. Okay, now we've got these guys configured. Let's take a look just to make sure that our interfaces table looks correct. And as you can see here, we've got our loopback and every single serial port on this device, all with the same IP address. So now let's configure OSPF, and we should be seeing a whole bunch of weird messages. All right, look at that. Forming neighbor adjacencies like mad. Now if you notice, in this example, we're referring to a loopback instead of the fast interface that we did in the previous version, and this is actually the correct way to do it. The reason is because if the interface that you're referring to with an unnumbered statement goes down, that interface also goes down, and it's a pain in the neck to get it back up. Loopbacks don't go down. So if you want to do this, the best practice is to create a loopback address that has the address that you want for all of your unnumbered serials, and then point all your unnumbered serials towards that. The other thing is that this does not work on Ethernet interfaces because they're not strictly point-to-point. Now, why in the previous example did I use a faster Ethernet interface for my serial unnumbered reference, if that's a bad thing to do? Well, mostly because it looks really funny and it confuses the heck out of people, and mission accomplished. I confuse a lot of people with that. So hopefully you can confuse people too. Good luck.